We're getting ready to start section 1 of chapter 2. And we have some keywords to place into items 1 through 4. So we'll give you a moment. We'll pause. And let's see how you do. Well, one of the things I probably should go over before we go over these is some simple review. Now, from chapter 1, we recall this is an ordered pair. And as we realize, the x, in a sense, is related to the y. So this indicates a relation. Now, the x items of every ordered pair are referred to as the domain. The y items of every ordered pair refers to the range. Now, if the x item is only used once, whatever value it is, in a series of ordered pairs, then it is a function. So these are some of the things to keep in mind as we look at these answers. So again, the key in number 1 is exactly one member. So it's only used once. That would be a function. The outputs, by the way, are referred to as the y. So that would be the range. And the inputs are referred to as the x. That would be the domain. And if they are related, that creates a relation. Okay, let's go on. Now what we're going to look at in number 5 is to determine whether this diagram represents a function. Now we're going to look at, is the x item, which is the first one, only used once? And the answer is yes. So this is a function. All right, how about in this example? Can you see that brown is used twice? So this is not a function. Now for number 7, as we look at it, we're talking about a box matching, let's see, the correspondent matching a box with its volume. So the box with its volume, as long as they're different boxes, that would be a function. Again, this one to me is not that clear. And by the way, if you're ever taking a test and something's not clear, you can ask a question about it. I won't tell you the answer, but we'll go over what they're asking. Now, as we do number 8, they're talking about the correspondence matching several students with the classes they are taking. So you would imagine that a student is taking more than one class and other students may be in that class or different classes. So where this is a relation, it's not a function. Now here they'd like us to write the range. Well, first the domain, then the range, and then determine if it's a function. Well, in set roster, we use a brace, and we list the elements. -3, -1, 5, and 0. That would be the domain. In fact, we often put a D there. Now for the range, it will be, again, the braces, 7. Okay, I filled this out here for you. There are 4 relations, 4 ordered pairs, and in our X position, none of them are repeated, and you could list them in order. And in the Y position, the zeros are repeated, you only write it once. But since none of the X items were repeated, it is a yes, it is a function. The X items are used only once. Those are the domain. Now in number 10, we'll notice here there's a -3 and there's a -3. Now I wrote it twice, but it's only to be written once, so I'll cross out 1. But because a domain item, an X item, is written twice, it is not a function. And here we see 5s are repeated. We only write them once, and we have a -5. So this is not a function because the X item is repeated twice. Now, theoretically, I shouldn't even put that there. So I should erase it. Okay, I wanted to emphasize that. Now, as we go on to example 11, here they're introducing, and we've done this in class, what is called function notation, where we say the function of x is such that, and then it gives you something over here. And this would be what the y value would be, because this symbol, the function of x, can be substituted with the letter y. Y equals something. And I'm going to suggest throughout this that we use a t-chart to sort of help us figure out what this is all about. So let's read this carefully. For letter A over here, they're saying that the x value, this x over here, is going to be a 1. So we put a 1 right there. Now, if x is 1, what will y be? Well, there's x1. Y is going to be 5. So that's where we put the 5. Now for letter B, they're asking us for the domain. So we look at all our points. We want to know our x values. So there's a -3, a -2, a 1, a 0, a 1, a 2, and a 3. So these are our domains for these points on the graph. Now for letter C, they're asking any x values for the function f of x equals 2. Now I did tell you that f of x can be substituted for a y. So in a sense, they're saying y equals 2. So I'm going to use our little t-chart here. And I happen to know there are 2 values. And you'll see in a moment. So where is y2? Well, y is 2 right there. And right there. So for this one, it's a -3. So -3, 2 is this one. And 0, 2 is this one. So when they give you something like this, they're asking, what are the values of x when y is 2? Because this can be substituted as a y. Y equals 2. When y equals 2, on this graph, the x value would be a -3 and a 2. And that's what we've put here. Okay? And then we're going to, so for this one, we're going to put, in a sense, oh, didn't do that too well, -3 and a 2. And our range, we're looking now for y values. So there's a -4, -2, 0, 1, 2, and 5. And I put them in already. Okay, now we're going to do the very same thing for number 12. So when x over here, when x is 1, we put a 1 right there, what will y be? Y will be 1. When x is 1, y is 1. So for this one, this is going to be a 1. Now in the second one, it wants us to write the domain. So what will the domain be? Well, it's going to start here at -3 and go right over here to 2. So it's going to be -3, comma 2. Now another way, if we put it in set builder notation, we'd say x is such, and bracket here, that -3 is less than or equal to x is less than or equal to 2. Now we had that in the previous section. So this is interval notation. This is set builder notation. And that was for number 2, the domain. Probably should put that there, t. And this is the range. Now here they're saying if y is 2, so I've put a 2 there. If y is 2, what will x be? Well, y is 2 is right there. Now what's your x value there? 0. And now we're looking for our range. And in interval notation, it's going to start here at 0. And it goes up to 5. And because of the dots, the 5 and the 0 are in the set. That's why we're using brackets. And in set builder notation, this would be a y now. It's going from 0 is less than or equal to y is less than or equal to 5. Okay, so this is some heavy math actually, and hopefully you get a handle on what's going on. Okay, for these now, they're asking us for the domain, and it's probably a good idea to put D equals and R equals. And I would suggest we do it in interval notation. So domain, remember, are our x values. And this goes all the way from negative infinity up through positive infinity. So in interval notation, negative infinity to positive infinity. And that is true for our range. It's coming up from negative infinity to positive infinity. Now, set builder notation would be for both of them. It would be x is a real number and the other one would be y is a real number. Now you might note, how come my writing is so bad? Well, I'm using a little tablet here, and it's kind of a little bit difficult to write with. Okay. Now for number 14, our domain, again, this eventually goes off here to negative infinity in this way, and this goes off to positive infinity. So for our domain, in interval notation is from negative infinity to positive infinity. Now for the range, and it would be the same as up here. Now here we're starting at actually negative 4. So we're going to use a bracket, negative 4, comma, and then it goes off to positive infinity. And for set builder notation, we would say y is such that y is greater or equal to negative 4. Now, it's perhaps easy to follow me doing these, but the test is when you do your practice and you quiz me that you're getting the right answers, and then of course mastering this so that when you do our test. Now, one of the skills we pointed out in our class is if we take a very, very thin line and carefully move it over the face of our graph, does this line, as it travels over the face of the graph, intersect the graph in more than one place at a time? So here it's one place, one place, one place. And we say in this case, it only intersects in one place. Then this is sometimes called the vertical line test. And if it only intersects in one place, it passes the vertical line test, and that indicates it is a function. So yes, this is a function because it passed that vertical line test. You see these lines, as they go over the graph, only intersect in one place. Now, just to show you an example of what it would be like if it didn't, let's have a little circle here, and we'll make a little graph there. So there's our graph, and as we do our line, does this red line passing over intersect in more than one place? Well, in the case of a circle, it intersects there and it intersects there. So a circle would not be a function. It would not pass the vertical line test because it's intersecting in more than one place. It can only intersect in one place for it to be a function. And I should have looked down at number 16. I would have seen there's our, it looks like an oblong circle. So ellipse, I believe, elliptical, and it does not pass the vertical line test since it intersects, let's say, there and there as it moves across the face of the diagram. So let's go on to number 17, and we'll show you some techniques. Okay, as we look over here, this is going to be an example of your typical function expression, where they're saying the function of x is negative 3x plus 1. Now remember, we could put a y there. Y equals that. Now, when they give you a value like this is the x value. So what I've done is I've made a t-chart and I've put my x values there. So I just take the value of 3, replace it in the expression here. So negative 3 times 3 is negative 9. Negative 9 plus 1 is negative 8. Now, if x is 0, negative 3 times 0 is 0. Y is going to equal 1. And if x is a, all we do is replace the x with the letter a, and we get this. So part of this is to understand the symbolism that is being used to show function values. Now another typical one would be this, but instead of now using the letter F, they're using the letter G. And now when they say the function of G, negative 2, that would be your x value. And you put that in your x value column, and then you just work it out. So if x is a negative 2, negative 2 squared is 4. 2 times 4 is 8. Minus 2 is 6. And then here, if we square 1/2, we get 1/4. 1/4 times 2 minus 2. Well, this becomes 1/2. Minus 2, we have to make it an equivalent fraction. So that becomes 4 over 2. And 1/2 minus 4 over 2 becomes a negative 3 over 2. And in this case, again, they're asking you some pretty heavy stuff. This 2 indicates that you're going to multiply this expression here by 2, which is what I have here. And you're going to substitute the G, which is your x value here, for the letter A. So all we're going to do here is put an A there, and then multiply this by 2. So this then becomes 4 x squared minus 4, which is what we have there. Now, those with a graphing calculator we're not going to do, but if you were to put an 11 where the b is and square it, that gives you 121, and then do this and this, and then add this to it, eventually it comes out to be 103. In these next few, we're kind of looking at this formula up here, and we want to find the surface area when the sides have the length of 7 centimeters. Well, again, I was attempting below to make a little square, but I didn't quite make a square here. Let's see here. That's better. Here, each side is 7. So 7 times 7 is 49. And how many sides to a cube are there? 6. So it's 6 times 7 squared is this. And here it's, again, a square, but I didn't draw a square very well. But it's 4.5 times 4.5 times 6, and you get this. So the key is, there's the formula, and where you have the S, that would be the length of the sides. You put that in there and square it. Then multiply by 6. Okay, for these, we're going to make a sort of a T-chart here, where they're giving you X values in this column, Y values in this column, and you have to solve using this basic equation. So if X is 3, a negative 3 plus 6 gives us a positive 3. Now if Y is 5, we're solving for that. Notice this goes over to this side. This becomes a negative 1 equals a negative X. So X would be a positive 1, which is what we have here. And then here, if X is a negative 2, and it's the opposite of a negative 2, the opposite of a negative 2 plus 6, this becomes a plus 2 plus 6 gives us an 8. Now the others are done the same way. And then here for number 29, you had to say what is the input if the output is negative 9. So here, this is your output. That's where you put the negative 9. And I've rewritten it, you want to solve for X. Transpose the 5. Divide both sides by a negative 2, you get X is 7. So your input here would be a 7, and your output would be a negative 9. Now, for this one, I'm going to show you the strategy of it. And let's make a little T-chart. So we're making a little T-chart here. And what they're asking is to determine the zeros. Okay, so there's an X and a Y. And we're wondering if the determining the zeros, we're looking for the X intercepts. So the X intercepts would be right here. That is where the line of our graph, this happens to be a parabola, would cross the x-axis. Crosses it there and there. Now, what are the values of y when it crosses the x-axis? The values are 0. So determining the zeros, if any, of each function. So in this case, this would be a 0, and this would be a 3. So the way they give the answer is they say 0, 3. Now this isn't an ordered pair. This is when you determine the zeros. It's just where the x-intercept, that is, the line crosses the x-axis where y is 0. That's what this is called, determining the zeros. Y is 0 when x is 0 and x is 3. And that's the answer. Okay, this is getting to be a little bit long, so let's see if we can speed it up a little bit. Again, we're looking for zeros, determining zeros, so our y value would be a 0. We solve the equation, x is 5. Now, when we want to find a domain and something is like this, that is, there's nothing in the denominator except a 1, then it is all real numbers. For this case, we take our denominator, equal it to 0, and we say that then x is a -3. So if x were a -3, a -3 plus 3 would make our denominator a 0, and we say that's undefined. So the domain of this would be any real number, but x cannot be a -3. So it's any real number, but x cannot be a -3. So the domain, all of these are what the domain are. And in this case, again, if there's no number other than 1 in the denominator, no variable, then the domain is all real numbers. And for numbers 35 and 36, we're not going to include this in our course. This is something for higher level math. And that'll wrap up section 2.1.